So let's start this session. So yesterday we started with the fundamentals, so data engineering fundamentals. So we started with what is data and what is compute. So today also we'll go through the fundamentals only. So we'll deep dive into a few more topics. The first one is coupled storage, which is a coupled storage and compute, and decoupled storage and compute. So when it comes to traditional databases, so traditional databases means any RDBMS, if you refer, all the databases are coupled storage and compute. Okay, coupled storage and compute means the same server will have a storage and same server will have a processing engine. So that we will call it as inbuilt storage and compute. Same server will have a storage, same server, it will have a processing engine. Storage means the data always stores on disk. Again, if you pick any database, the data always stores on disk. And whenever we read data through client, SQL client, SQL is not a database, it's a language, query language, structured query language. Whenever we go and write a query to read data from a database, first the query will be submitted on processing engine. So that we will call it as instance or processing engine, where it will process on CPU and RAM. It will process on CPU and RAM. You can pick any database. So the database's architecture will be like this. That databases may be a C++ based database or maybe Java based databases. Any database you can pick, maybe DB2, Oracle, SQL Server, any database. So those structure will be always inbuilt storage and inbuilt compute. So you can't separate them. Consider I can't separate storage and we can't use a separate storage, separate processing engine. Consider if this processing engine is not available, you can't read this data. That is not possible. Always that instance should be available to read the data. Always that instance should be available to read the data. So that kind of architecture we will call it as coupled storage and compute. So big data, we have a separate concept, decoupled storage and compute. So what is exactly decoupled storage? And what are the major advantage of this architecture? What are the major advantage of this architecture? So it stores data separate always. It stores data separate. And the compute will be a separate. That may be a Spark, that may be a Hadoop MapReduce. Okay. The storage may be, if it is a cloud, like Azure Data Lake is a cloud, data lake storage if in Azure. Similarly, AWS will have S3 and GCP will have a GCS. And open source on-premises we can find Hadoop HDFS. So these kind of storages will called as DFS, distributed file systems. Distributed file systems. DFS. Data lake or distributed file system, whatever name you can call it as, that those are storages. Unlimited storage, hierarchical namespace storage. Hierarchical namespace means you can have a number of files and number of folders. You can go and store the data. So data storage is separate, means decouple. So compute and storage will be decoupled. So, and your processing engine. So processing engine means whenever you write any query and submit, and that engine will have always separate. That may be a Spark. Spark is one of the processing engine. Spark is one of the processing engine. Like database will have instance. The instance is same as like Spark. Okay. Database instance will call it as Spark server. But database instance is a coupled, okay, which you can't separate them. Okay. Which you can't separate them. It's always inbuilt. It's always inbuilt. There are many companies are providing a decoupled system. Like Snowflake is one of the main thing when you come to databases. Database itself, you have a decoupled storage, decoupled systems. One is Snowflake, BigQuery, okay, Redshift. So these kind of services are decoupled. Similarly, Fabric is having a SQL data warehouse, so that is also decoupled. That is also decoupled. And Teradata also distributed. Teradata also distributed. So if you just Google it, you will have a lot of information about decouple data warehouses. Decouple distributed data warehouses. Okay. So Snowflake is one of the popular data warehouse in cloud. And Databricks Lakehouse is also decoupled. Amazon Redshift and Google BigQuery. And the open source one is Apache Doris. Even there are many are there. Okay, there are many are there. So ClickHouse is there. There are many companies are providing decoupled system. Decoupled system means it's always stores data separate, process data separate. Stores data separate, process data separate. So for that, what I'll do, I'll show you one example directly with this Snowflake. What is exactly a decouple and the advantage of decouple? So anyway, Databricks we have, but let's go with outside Databricks. What is exactly a decouple system? So what I'll go to the snowflake.com. So we can go and create a free trial in Snowflake. You will get a 1 month of free trial with a $400 credit. You can use your personal email ID. So what I'll do, I'll go and use a personal email ID. Let's log in on email ID. So you can choose any cloud platform here. I'll choose AWS. Just enter the personal skip. So I should get an email from Snowflake to activate this. So I need to create a username password here. Okay. Okay. Snowflake also you will have. You can go and create an like a notebook will have a combination or only Python worksheet or only SQL worksheet you can create. Let's go with only SQL based. So this is the default workspace. So let me create a, okay. So when you go to this menu. Here you can find the left side menu. There we have a catalog. Catalogs means where you can find the sample databases. Okay, these are TPCH different sample databases. Here also you can find the tables. And similarly, compute. This is storage, separate storage and separate compute. Compute is available here. We'll call it as virtual warehouses here. I'll create a compute one, like multiple compute I'll create, okay? Compute one, okay, I'll go with 2x small. Okay, this is x small compute. I'll go and create another compute 2. Okay. So maybe we can, this is the compute one. So data analyst, compute, just I'll rename it. Okay. Okay, so I renamed this. Let's back to projects, workspaces. This is our SQL notebook. So here we can choose a compute. So I'll choose data analyst compute. Okay, data analyst compute. Then we can choose a particular catalog and the table, schema and table. The sample TPCS schema. So we have multiple tables are available. So I'm executing query, we can see the data. So data storing separate, and this is a compute. So we just now we created a compute. Compute is just a processing purpose only. Mainly it uses CPU and RAM. Disk will be the temporary disk, but disk is temporary, not permanent here. Only CPU and RAM is main focus. If I go and use another compute 2, I can run the query, I can read the same data. So similarly, Databricks also you will have a separate storage, separate compute. Databricks also you'll have a separate storage, separate compute. Advantage here it is, why we need a separate storage, separate compute. You can go and store data in one place. That may be any cloud platform. And the processing engine based on need, consider cloud is pay-as-you-go. Pay-as-you-go means storage is cheaper. Per month, you have to pay per terabyte. If you have 1 TB data per month, maximum cost will be $30 per 1 TB per month. Okay. Cheapest storage. The storage is cheaper, but compute is costly. Compute means CPU and RAM is costly. CPU and RAM is costly. Disk is cheaper. That may be a hard storage or cold storage, but disk is always a cheaper. So cloud is providing a separate storage services that is called data lakes. It's a cheaper for us. 1 terabyte if you have a data per month, you have to pay $30, $20 to $30. It depends on the region, but that will be a cheaper price. If you have a 2 terabytes, then $60 per month, cheapest storage in cloud. But compute is different. Compute means they'll charge per minute. If you are running a CPU and RAM compute, per minute they'll charge. Consider per hour, maybe $2. So if you run 10 hours in a day, then $20. This is per day. I'm just giving a simple example. Like if you run 20 days in a month, then it will become So that is only for one compute. Like project obviously will have a different teams. You'll have a data engineering team. Okay. Project always will have a different teams. You'll have a data engineering team. You'll have a BI team, business intelligence like reporting, and you'll have a data analyst or a data scientist. Okay. Data scientist team. So maybe data engineers they'll use for development, testing. BI they'll use for creating reports and dashboards. And then data scientists they'll create analytics, like advanced analytics. And then you will have another business users also. Business users for consumption. For them also compute is required. So if you are running a compute on multiple hours, if it is not separated, then storage should be available always. So if you are going with coupled storage, then it should be available 24/7. 24/7. So you are going to pay every minute if it is coupled storage. If it is decoupled, consider data engineers are not working on weekend, then this won't be working. Means that compute will be not available, they won't charge. Business intelligence people, maybe they are working every day 2 hours or 3 hours. Okay, so they are not utilizing much. With data scientists working per day 8 hours and they're not working on weekend. So that weekend cost you can avoid. That weekend cost or other timings cost you can avoid. Business people, maybe they'll access every day in the morning hours, maybe 1 or 2 hours. And after that, they won't access that. Let's consider maybe 2 hours or 3 hours. Only you have to pay that. The remaining time, this compute you can shut it down. You don't need to pay that. So you can shut it down, this compute. Your storage will be available always. Whoever want to access, they can access. The storage will be available always. Storage is cheaper. It's a fixed pricing per month. It's capacity basis. Even if you run 100 times also, capacity wise only they'll charge. Compute is different. For compute, capacity basis and timing basis they'll charge. Compute, capacity basis, timing basis they'll charge. But storage always will be a fixed storage. So that's the advantage of decoupled system. Okay. So big data services or cloud data warehouses are distributed and decoupled. Even this also distributed, or processing engine is distributed, storage is distributed. So it will split and store the data, will called as distributed file system. Split and store the data, distributed file system. Store the data, permanent storage. This is split and process the data, where it will process RAM and CPU. Distributed processing engine. So what is exactly distributed? It will split and process on multiple nodes. So processing engine always process on CPU, RAM. Processing engines always process on. If it is a distributed system for storage, it will store on disk. Both are distributed. Okay. Distributed processing engine, it's process on CPU and RAM. Distributed storage, it will store on disk. But both are distributed. So what is distributed? You'll have multiple nodes. There's no limitation on number of worker nodes. Worker nodes or process nodes. Worker nodes means if it is storing, we'll call it as worker node or as data node. If it is only processing, we will call it as process node. So this is about distributed systems. The distributed systems means It may be a Snowflake, it may be a Redshift, it may be a BigQuery, it may be a Databricks, it may be a Fabric. All are having distributed compute for processing. And when it comes to storage, AWS S3, Azure Data Lake, Google GCS, Google Cloud Storage, and the open source HDFS. The name itself is there, Hadoop Distributed File System. HDFS means Hadoop Distributed File System. These all are DFS, Distributed File System. Distributed File System means it will go and split and store the data on multiple nodes. That is called storage service. We will call it as data lake. Data lake means if it is going to split data and store data on multiple nodes, we will call it as distributed storage. So advantage here it is, you can store once and read multiple times. Okay, store once, or you can say write once, read multiple times. So that's a basic concept of big data or any analytics field. Write once, read multiple times. That's the concept of big data. Or you can say in a distributed system, concept is write once, read multiple times. So what is WOM? So write once, read multiple times means you can store data here. The data is cheaper price. Just only storage cost you have to pay, and processing maybe you can use for data engineering. Processing you can use for maybe BI. The processing you can use for data scientist or business analyst or maybe end users. But that compute you can use only a pay as you go. If you are using, you have to pay. If you're not using, you don't need to pay. So this is the concept of decoupled systems, decoupled storage and compute. Snowflake is decoupled. This is the best example to understand. Same table I can read from another compute. This is another compute. Same table. But table storage is different. So if you go to here, you can find the catalog. Here it is the storage. All the tables you can find here. But the compute is here. Compute is here. So where you'll have a different computes. You see here multiple computes. Okay.
Sir, one question.
Yes.
We are reading data from another compute, but if that compute is offline, so will we able to, or will we be able to? Because storage is different.
Can you repeat your question? Your voice is not clear. Maybe you can speak a little louder.
Okay, we have multiple compute. And,
Maybe you can come little closer
now
to the mic.
Now, sir?
Yeah, now it's fine.
Yeah, we have multiple compute and storage is common. So we are reading data from another compute data from another compute. So if that compute is offline,
your compute 1, you can read from compute 2, you can read from compute 3. Okay, what is your question? Can you repeat again?
If the compute is offline, how can we read data from another compute?
That's right. This is separate compute. This is separate compute. If you are online, then you can read this. If it is offline, that user cannot read. Similarly, this user will have one compute. This user will have one compute. Okay. If you're not reading, right, consider you are a data engineer. You are working only 8 hours. Remaining out of 24 hours, remaining hours, if you're not using, why you need to pay unnecessarily to the cloud service providers, right?
Yeah.
You can go and shut it down. Okay. So data engineers may be running for 8 hours per day. The remaining hours, they can shut it down. What they can shut it down? They can shut it down only compute. But storage will be available always. This will be available always. And consider another team, maybe a BI team, they're accessing maybe a few hours per day. Remaining hours, if they're not using, so they can shut it down. Tomorrow, when they want to use, again, they will start the service. Okay, clear now?
Okay. So the storage is shared.
So that is a concept of decoupled systems. Simple, easy to understand. Best example is tractor. So tractor, you will have engine separate, and then tractor storage separate. Okay, that is similarly train. Train is a decouple. The tractor is decouple. So what is a couple? Your car, bus, these all are coupled. You cannot separate them, right? If engine is not working, you cannot take that vehicle. That may be a car, that may be a bus. Those all are couples. Both are coupled. Car, bus, storage couple, and compute, which is engine is couple. If engine is not working, you cannot take that bus or car. But if it is a tractor, if one engine is not working, then you can go and attach another engine and you can take it that. Similarly, trains also. Train best example for a decouple. Train, goods train or passenger train. Engine is separate. You can attach and detach whenever you want. Okay, clear now?
Yes, sir. Yes.
Okay.
And Ravi, one more thing, you can separate this capacity CPU and everything based upon the jobs is separate, and user when the UI point of view it's a different. We can create
Yes.
dynamically that one.
Here you can have a more capacity. Here you can have a lesser capacity. Here you can have a medium capacity. That is always based on the demand, based on requirement. Okay, that compute processing capacity, you can use any capacity, but storage always will be unlimited. You cannot decide like how much you want to store. That is unlimited. If it is unlimited means like there's no defining saying that I want to store this much data. But compute is always pay as you go plus demand basis. So if it is demand basis, you can use a less compute if you have a requirement of less. You can use more compute if you have a more requirement. Okay, clear now?
Okay. Yes.
Any other questions?
Snowflake is similar to Databricks.
Yes, all are distributed, but those Databricks is using open source. Snowflake is proprietary. Okay.
Oh, okay. So it is a competitor for Databricks.
Yeah.
Okay.
But purpose is different. Totally purpose is different. Snowflake came from mainly for data warehouse. Databricks comes with mainly for data science and AI use cases. Okay. Advanced analytics use cases. But both are distributed systems, but purpose and the services, softwares totally is different. Databricks uses everything is open source, but Snowflake uses proprietary. Proprietary means internally when it is storing the data, right? The data file type, processing, everything will be their own proprietary. They won't reveal that. Okay. But Databricks is using anyway Spark. Spark is open source.
But sir, Databricks, we need to pay license for using Databricks, right? No.
So cloud systems are not license based. Cloud systems are pay as you go based. Okay. On-premises softwares are license based. Consider your Windows. If you want the Windows software, right, you will purchase a license for 1 year. Consider you're looking for a database. A database you'll purchase for 1 year or 2 years, 3 years license. Consider you're looking for ETL softwares. So those are license based. Proprietary softwares are license based on-premises. Cloud is different. Cloud, you don't need to purchase any license. Okay. It is like Ola or Uber. So consider if you go to the Amazon Prime, Netflix, those are subscription based. You have to purchase maybe monthly basis or yearly basis. Okay. Or you have option to go and purchase one movie and then watch only that movie. Okay. You'll have a both. Subscription based will be there and usage based will be there. But when it comes to Ola or Uber always will be usage based, not subscription based. So if you are booking a 2 cabs, you have to pay for that only. You don't need to have a subscription for yearly or monthly. So that's the difference between usage model and subscription model. Pay as you go, we will call it as. Pay as you go means if you are using, you have to pay. If you're not using, you don't have to pay. But
so
Prime, Netflix, these kind of services are subscription model. Even if you are using or not using, first you have to purchase the subscription maybe yearly or monthly. So that's the difference between subscription based and pay as you go model.
Okay. So to whom we are going to pay? To Azure Cloud or to Databricks?
It's wherever it is. If it is in Azure, it is Azure. If it is AWS, it's AWS. If it is GCP, it's GCP.
Okay, not to the Databricks vendor. Okay.
No. Databricks, that's what Databricks, everything is using open source, but they will charge their price, which is a software, entire application pricing, through a particular vendor. Vendor means if it is Azure, they'll charge through Azure. Okay. If it is AWS, they'll charge through AWS.
Okay, sir. Thank you.
Okay. Any other questions? Okay. So let's understand that local file system versus distributed file system. So what is local file system? Local file system means consider your laptop, your mobile, or your desktop, those kind of file systems. Okay. We'll call it as local file system. Every operating system comes with a local file system. So those are NTFS file system, FAT file system, EXT file systems. Okay. So Windows operating system comes with one file system software. Consider I'm using a MacBook. So MacBook also comes with a software, file system software. Okay. So you can go and Google it. You will have that information. Windows OS versus Mac OS versus Linux OS file system. Okay. NTFS is a file system. NTFS is the file system. Comes with a Windows. Similarly, apps will have a APFS. Okay, app will have a APFS. Linux will have a EXT and FAT file system. EXT and FAT file systems. These are different file systems. We will call it as local file systems. Every operating system, I'm using a Mac, right? So Mac comes with APFS, Apple file system. So what is exactly a file system? A file system is a software. It will help you, it will give you user interface and CLI both. Okay. What is the user interface? GUI, or you can say user interface, UI. Graphical user interface or user interface. This is a graphical user interface, which I can go and copy files, which I can go and get the files information, which I can go and delete the file. This kind of interface is called graphical user interface. Same thing I can go and CLI also, command line interface. This is command line interface. The file system is going to give you two options. One is you can interact with that file system through commands. You can interact with a user, which is graphical user. I will call it GUI. Okay. So every operating system comes with its own file system. If you are using a Windows, you will get a NTFS. Because you are purchasing a pen drive. Pen drive also comes with the operating software. That software. If you are purchasing a external hard disk, that hard disk also comes with that software. But these file systems will called as local file systems. So what is exactly a local file system? So this file system is not distributed. These file systems are not distributed. Okay. So standalone storage, we will call it as not distributed. We'll call it local file system or standalone storage, not distributed. It may be a Windows. It may be a Linux. Linux comes with EXT and FAT file systems. So EXT and FAT file systems. Linux also will have different flavors. Red Hat is available, Ubuntu is available, like plenty of flavors are available. Okay, EXT is one of the file system you can use. You can see in most of the Linux flavors. Linux also open source operating system. Okay, different versions use EXT1, EXT2, EXT3, EXT4, different years. This is also open source file system. Open source file system. It will have limitations. You can't go with a petabyte size. So EXT2 maximum it will support 2 terabyte size. Later they increase to 32 terabyte. EXT4 is the latest one from that, which will support 16 terabyte size. That's the maximum support capacities which that operating system is going to support. Similarly, FAT file system. It's also open source. FAT will have a FAT 12, 16, 32, will have different versions. Okay. This also which you see in most of the open source operating systems. Open source operating systems. There are plenty of open source Linux flavors are there. Okay, you can search list of Linux operating systems. There's plenty of open source operating systems which you can find. Okay. Fedora, Red Hat, Ubuntu. Okay, Databricks uses all open source services. Spark is open source, operating system also open source. So whenever you create a compute, right, or whenever we run a program, backend it is going to use a Ubuntu operating system. It is also open source. Okay, so there are plenty of Linux operating systems are available. Those operating systems also need a file systems. Those file systems you can find some in a FAT file system, some in ext file systems. Windows uses NTFS file system. Mac uses APFS file system. Okay, so you can search here what is NTFS file system. Okay, so NTFS is from Microsoft since they started in Windows XP, and initially they have a supports file sizes up to 4 GB. Later they increase that capacity in the later versions. Okay. Microsoft is having NTFS file system. Okay. These are different file systems, but all are local file systems. Local file system is that will work on a particular operating systems, and one node means locally it will be available. So what's the difference? What is a distributed file system? Local file systems means consider you have a data, consider you have a 40 TB data you want to copy into a particular location. So that only it will process on that machine. It is like individual developers. Consider you have 100 hours of work. Okay, the work is not distributed. If work is not distributed, if you have 100 hours of work, so then you have to do that work. Consider if per day if you are working 8 hours, then those many number of days it will take if the work is not distributed. So those kind of file system will called as local file system. So if you have a 40 terabytes of data, if you want to copy on one machine, it will take 4 hours. If that is distributed means you have 4 missions, mission 1, mission 2, mission 3, mission 4. You can split this data and process on 4 missions parallelly. So 10 terabytes in each mission, so 40 terabytes. So total 4 missions, it will copy the data in 1 hour. So here it is, you are distributing the data, a piece of work you are distributing. So the file system also should support to split data and process data on multiple nodes. So this will call as nodes. We'll have one disk here, one disk here, one disk here. It will split the data and process the data. So that kind of file system will call as distributed file system. So this file system will call as local file system. Local file system may be NTFS, maybe ext, maybe FAT, maybe APFS. Apple file system, Windows file system, or Linux file system. These kind of file systems will be called as local file system. So what is a DFS? Distributed file systems. It will split data and process and store on multiple nodes. Distributed file system. So Hadoop introduced this HDFS, Hadoop Distributed File System. This is one of the open source file system. So Hadoop always works on multiple nodes, where it will split data and process and store on multiple nodes. Okay, that may be n number of nodes. That may be n number of nodes. So every cloud is having a distributed file system that is called data lake. Distributed file system, another name is data lake. So what is data lake concept? So general, what is lake concept? Lake concept means if rain comes, the same water will go and store on lake. If any drainage water also come and store on lake, means anything it can go and store. The water comes from maybe a factory, the water comes from rain, the water comes from any homes drainage systems, that also come to and store in a lake. So what is a lake? Lake where is area where you can store a huge amount of water. That water may be a good water or bad water. Similarly, what is data lake? Data comes from any systems, maybe any file, any type of file, any system, any size. You can go and store directly. You can go and store directly. That is called data lake concept. Data lake concept is, it may be good, it may be bad. It may be any size, it may be any file or n number of files. N number of files. So data lake concept is storing raw data. The raw data may be any file format, any sizes, unlimited storage. So data lake concept is unlimited storage plus any file sizes, any type of file like structured, semi-structured, unstructured files, plus that may be a quality data or bad data. It doesn't matter because it won't verify if the data is having good data or bad data. It just will allow and store that information. So data lake is nothing but distributed file system. So data lake is nothing but distributed file system. Advantage here it is, it will split the data and store data on multiple nodes. So advantage of distributed file system is you can copy any number of files or any sizes of data in a lesser time because it is going to copy on multiple nodes. So you can reduce that processing time. Local file system always uses single. Distributed systems uses multiple compute, where it will split and store data on multiple compute. So that's the differences here when it comes to local file system versus distributed file system. Local file system versus distributed file system. So I'll pause here. If anyone is having any questions, you can ask me now.
Yeah, sir, one question. Like data is there in the data lake. So one particular compute takes the data from the data lake, it processes it, and the data goes back to the data lake.
Here, one thing we need to understand, data lake means it's a distributed file system. Consider you have a file which is maybe a 10 terabytes data. You want to copy into somewhere. You want to store into somewhere. So if you are storing in a local file system, it will take more time because it uses one compute only. It is like, consider you have only one developer. You have hundreds of developers. So what's the difference between one developer and hundreds of developers? ASCII values. Then it will identify the uniqueness based on that. Okay, file names. File name is always unique. Okay, file name is always unique. It will create at runtime. Then it will send here. As the same file, it won't send to another worker node. Okay.
Okay. So like the code modification yesterday we did. After that we did some changes.
So like if you are talking about a code versioning, you will have a Git versioning control. Similarly, Databricks notebook by default comes with a version control. Every notebook, whenever you go and modify it, you will have a complete tracking. When you modified, which line you modified, and yesterday you did some modifications. Today you did modifications. You did some modifications. Tomorrow also you are doing some modifications, right? Everything will be tracked. That is code level. Notebook level, you will have that feature. Okay. Similarly, when it comes to data level, data lake does not support a time travel. Okay, that concept we will call as time travel. Time travel means going back and getting a particular version. That's called time travel. Data lake does not support, but you need some file system software to support versioning. So Delta is a API which it uses in Databricks. It is also open source. Delta supports the time travel. Okay, that's versioning concept. On the data side, Delta is going to support, not a data lake. Okay.
Okay. So,
Data lake is different. Your code base is different, and data lake is different. All are different concepts.
so how this data lake is being backed up, sir?
Data lake always uses huge servers. Servers means disk storage in data centers. So if you are talking about Azure data lake, it stores in Azure cloud data centers. If you talk about AWS S3, it will store in AWS S3 data centers. Similarly, GCS. Okay.
Okay.
So every cloud is having their own data storage that we will call as data lake. Azure data lake storage, AWS S3, GCP, GCS. Okay. AWS, Azure, GCP. Okay. Okay. Any other questions?
Sir, what mechanism used to these compute and storage we can connect, right?
Client, always your client. When your client is always you will interact. Okay. Without client, you cannot interact with the storage and compute. So always your client. So what is your client? Your IDE, nothing but your notebook is your client. Using your notebook, you will run a queries that is called code. That code you will submit on the server. The server is processing server. Okay. That is Spark.
Okay.
Your IDE is required. Consider if you are Java programmer, right? So you need IDE. If you are a .NET programmer, or if you are Python programmer, so you need IDE to run a program, right? Similarly in Databricks, so you will use a notebook as IDE.
Okay.
So using a Databricks notebook, you'll write a program, and that program you will run, and you will run on the server. The server is processing server, which is Spark. Okay.
Okay.
Okay. Any other questions? So today we are done with the fundamentals before starting our session. So tomorrow we will kickstart.
Thank you.
Thank you. I'll see you tomorrow.